Welcome back to our Advanced User Interface Technologies course. In today's lecture, we are going to learn one of the most important concepts in Redux, Redux actions and combining reducers. If you have already learned what Redux store and state are, today's class will help you understand how data actually moves inside a Redux application. By the end of this lecture, you will know what actions are, what creators do, what reducers are, why multiple reducers are needed, how combined reducers work, how everything works together in a real application. So let's begin. Learning objectives. Before starting, let's understand our learning objectives. After completing this lecture, you should be able to define Redux actions, explain action creators, understand reducers, explain why applications require multiple reducers, understand combined reducers, build a simple Redux application structure. Think of today's class as learning the communication system inside Redux. React displays the UI, Redux stores the data. Today's topic explains how the data reaches the store and how it gets updated. What are Redux actions? Let's first understand Redux actions. Imagine you are shopping online. You click the Add to Cart button. Does the cart automatically update? No. First, the application needs to tell Redux that something happened. That message is called an action. A Redux action is simply a JavaScript object. It describes what happened. The store never guesses what the user wants. Instead, it waits for an action. An action usually contains two parts. The first is type. The type tells Redux what operation should happen. Examples include add product, remove product, login user, logout user. The second part is payload. Payload carries additional information. For example, if adding a product, the payload contains the product details. Example, the type is add product. Payload consists of ID as 101 and name as laptop. Notice something is important. An action never changes data. It only describes an event. Think of an action like sending a message. Please add this laptop. The action itself does not add anything. Someone else will process it. Now let's understand the flow shown in the diagram. User clicks button, action is created, and then dispatch sends it, reducer receives it, store updates, React automatically displays the updated information. This is the complete lifecycle of every Redux update. Action creators. Writing action objects repeatedly becomes difficult. Instead of creating objects manually every time, we create functions. These functions are called action creators. Example, function increment, return, type increment. Notice this function only returns an action object. It does not update the store. It does not change the state. It simply prepares the message. Advantages include reusable code, less duplication, easy maintenance, cleaner applications. Suppose your application has 50 buttons. Instead of writing type as a login 50 times, you simply call login user function. That's why action creators improves software quality. The flow diagram shows clicking on the button and then the action creator and then the action object. Dispatching actions. Dispatch function. Now comes the most important function, dispatch. Dispatch is responsible for sending the action to Redux store. Without dispatch, Redux never receives the action. Example, dispatch type add product, payload product. Let's understand this step by step. Step 1, user clicks add to cart. Step 2, action creator creates an action. Step 3, dispatch sends the action. Step 4, reducer checks the action type. Step 5, reducer updates the state. Step 6, store saves the new state. Step 7, React automatically updates the screen. Let's remember who updates the Redux store. Not dispatch, not action. The answer is reducer updates the state. Dispatch only delivers the action. The diagram shows the user and then the dispatch function and then the reducer and then the store and then finally updated UI. Understanding reducers. Now let's study reducers. Reducers are the heart of Redux. A reducer is a JavaScript function. It accepts the current state and action and then returns a new state. An example code is given. It uses the function counter reducer and then the switch case. So the first case is responsible for increment and it returns the state plus 1. The second case is responsible for decrement and it returns the state minus 1. The default case is responsible for returning the state. Let's understand this. Suppose current counter value is 5. User clicks increment. Action type becomes increment. Reducer receives state equal to 5, action equal to increment. Reducer returns 6, Redux stores 6, React displays 6. Simple. Now notice another important concept. Reducers are pure functions. Pure means same input, same output, no randomness, no API calls, no database access, no timers, no direct state modification. Instead of state.count++, always return state count plus 1. Never modify existing state directly. Always creates a new state object. This makes the debugging easier. Why combine reducers? Now imagine building Amazon. Would one reducer handle everything? Login, orders, payments, products, wish list, cart, reviews, address? Impossible. One reducer would become thousands of lines. Maintenance becomes difficult. Instead, Redux encourages one reducer per feature. For example, user reducer, cart reducer, product reducer, order reducer. Each reducer is responsible for only one section. Advantages includes easy testing, independent development, better scalability, cleaner project structure. Large companies like Amazon, Netflix, and Flipkart follow modular architecture. Combine reducers. Now the question is, if we have multiple reducers, how does Redux use them? The answer is combine reducers. Let's look into the syntax. Import combine reducers from Redux. Notice something interesting. The keys user, cart, products become separate sections inside Redux store. The final state looks like user, cart, products. This is called the root reducer. Redux automatically sends each action to every reducer. Only the appropriate reducer updates its state. Others simply return the previous state. The benefits includes organized code, easy maintenance, and modular architecture. Combined reducer architecture. Let's connect everything using an online shopping application. Suppose the user logs in, login reducer updates login information, user adds a product, cart reducer updates cart, user searches products, product reducer updates product list, user places an order, order reducer updates orders. Every reducer handles only one responsibility. This follows the software engineering principle called separation of concerns. The data flow becomes user, action, dispatch, root reducer, specific reducer, Redux store, React UI. Advantages include independent modules, easier debugging, and better scalability. So this is what the real-time example for the online shopping application features login, cart, products and orders. So this is how the data flow will be: user action, dispatch, specific reducer, Redux store and updated UI. Advantages and best practices. Let's summarize today's lecture. Today we have learned actions describe events, action creators generate actions, dispatch sends actions, reducers update state, reducers are pure functions, combine reducers combines multiple reducers. Finally, the best practices includes keep the reducers small, use meaningful action names, never modify the state directly, always return the new state, separate reducers feature-wise. These practices make Redux applications scalable and maintainable. So the key takeaways of today's lecture: actions describe what happened, action creators create reusable action objects, dispatch sends actions to the store, reducers update the application state, combine reducers function merges multiple reducers into one root reducer. Combining reducers improves maintainability and scalability. So thank you for watching this lecture. See you in the next lecture. Happy learning.